June 7th, 1944. Oberst Friedrich Hoffmann stands in a concrete bunker overlooking what was, 24 hours ago, a section of Normandy coastline the Wehrmacht controlled absolutely. Through field glasses still speckled with yesterday's cordite residue, he counts landing craft, 37 visible from his position alone, disgorging men and material onto beaches that should have been graveyards. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. They keep coming, wave after wave. Plywood boats 36 feet long, carrying troops, jeeps, supplies, then reversing off the sand and racing back to ships waiting beyond the horizon. The rhythm never stops. 6 minutes, from ship to shore to ship again. Industrial choreography operating at a scale that makes Hoffmann's throat tighten. He's 42 years old, a career officer who fought in the Great War, studied logistics at the Kriegsakademie, and spent 3 years planning coastal defenses. He knows mathematics, he knows production capacity, and as the morning sun burns through channel mist, he's performing calculations that terrify him more than the shells that bracketed his position yesterday morning. Each of those landing craft represents industrial capacity, raw materials extracted, processed, assembled, engines built, ramps engineered, crews trained, logistics coordinated. That's not 37 boats out there. That's 37 complete industrial processes operating simultaneously, delivering combat power to a hostile shore faster than German forces can respond. Hoffmann lowers his field glasses and reaches for the intelligence summary on his desk. Yesterday's preliminary count from his sector alone, over 400 landing craft observed during the initial assault hours. 400. Multiply that across 5 invasion beaches, and the number becomes incomprehensible. Thousands. The report in his hand, compiled by Fremde Heere West, German military intelligence for the Western Theatre, contains something more disturbing than casualty figures. A single line buried in technical assessments. Allied landing craft production estimated at minimum 12,000 units annually. Potentially higher. 12,000 per year. That's 33 landing craft every single day, including Sundays, including Christmas. The Americans are building landing craft at the rate of more than 1 per hour, around the clock, sustained across 12 months. Hoffmann does the mental arithmetic. German officers learn to perform in North Africa, Italy, Russia, convert enemy material superiority into tactical implications. If the Allies can produce landing craft at this rate, how many other things are they producing that we're not seeing yet? How many tanks, trucks, aircraft, artillery pieces flow from factories we can't bomb? The war has been underway for nearly 5 years. The industrial mobilization mathematics are brutal and becoming more brutal by the hour. To understand how this moment arrived, how a German colonel in Normandy could find himself overwhelmed by plywood boats, you have to rewind the war to when Germany's military seemed unstoppable and the Allies appeared dangerously unprepared for amphibious operations. September 1939. The Wehrmacht conquers Poland in 27 days, using blitzkrieg tactics perfected over years of rearmament. German industry has been retooled since the mid-1930s for military production. Tanks, aircraft, artillery flow from factories operating under centralized planning that prioritizes military requirements above all else. The German war machine in 1939 represents the most technically advanced military-industrial complex in Europe. Krupp, Daimler-Benz, Messerschmitt, Rheinmetall. These firms have been developing military technology while Britain and America remained largely disarmed through the Depression decade. When Germany invades France in May 1940, the disparity is stark. Wehrmacht units equipped with modern weapons, coordinated by radio, supported by tactical aircraft, defeat Allied forces still relying partly on Great War methods. The conquest takes 6 weeks. Paris falls on June 14th. Britain evacuates from Dunkirk, leaving behind thousands of tons of equipment. Adolf Hitler, surveying his victories, makes a critical assessment about his enemy's industrial capacity. American production potential worries him theoretically, but in 1940, America isn't at war and shows little appetite for European entanglements. Roosevelt pushes for rearmament, but isolationist sentiment remains powerful. American military production in 1940 is negligible by European standards. British industry is formidable, but constrained by geography. The island nation imports food, fuel, raw materials. U-boats can strangle supply lines. Strategic bombing can disrupt factories. Hitler calculates that Germany, with access to European resources and labor, can outproduce Britain in a war of attrition. The Soviet Union's industrial capacity is unknown, but presumably inferior. Stalin's purges have gutted military leadership. The Red Army performed poorly in Finland. Hitler dismisses Soviet production potential as irrelevant because Barbarossa will conquer the USSR before its factories can matter. These calculations dominate German strategic planning through early 1941. The war will be won quickly, before enemy industrial mobilization can change the balance. Each campaign must achieve decision before the enemy adapts. Speed, aggression, superior tactical skill will overcome any long-term material disadvantage. It's a gamble built on Germany winning fast because Germany cannot win slow. Amphibious warfare barely factors into German planning. Operation Sea Lion. The proposed invasion of Britain gets shelved after the Luftwaffe fails to win air superiority in 1940. The Kriegsmarine lacks purpose-built landing craft. German military doctrine emphasizes land warfare supported by tactical aviation. Amphibious operations receive minimal attention and even less industrial investment. The landing craft Germany does develop are improvised. The Marinefahrpram, essentially a powered barge, gets designed for Sea Lion but doesn't enter production until 1941, too late for the operation it was meant to support. About 700 eventually get built, most used for coastal supply work rather than assault landings. These vessels are adequate for their intended role, moving men and equipment across calm Baltic or Mediterranean waters to unopposed or lightly defended shores. They're not designed for contested beach assault against prepared defenses. German military thinking doesn't prioritize that scenario because Germany fights a continental war of maneuver, not an amphibious war of logistics. Meanwhile, across the Atlantic, a different industrial philosophy is taking shape. Andrew Higgins runs a small boatyard in New Orleans, building shallow draft workboats for oil prospectors and trappers operating in Louisiana's bayous and marshes. His Eureka boat, designed in the 1920s, can operate in 3 feet of water thanks to a recessed propeller and spoon-shaped bow that lets the craft run up on mudbanks and back off without damaging the hull or getting stuck. Marine Corps notices. Marines have been wrestling with the amphibious warfare problem since the Great War. How do you get troops from ship to shore when the enemy controls the beach? Climbing over the sides of conventional boats exposes men to fire. Boats that draft too deep can't reach shore. Propellers get damaged in surf and sand. Higgins's Eureka design solves several problems simultaneously. Shallow draft means it can beach itself. Recessed propeller means it won't get torn off by sand or coral. The spoon bow means the boat can extract itself after unloading. What it lacks is a way to unload cargo quickly. The solution comes from an unlikely source. Marine Corps Lieutenant Victor Krulak observes Japanese amphibious operations in China during 1937. The Japanese use small landing craft, equipped with bow ramps that drop down, letting troops and vehicles drive or run straight onto the beach instead of climbing over sides. Krulak brings photographs back to the United States. He shows them to Higgins, suggesting a ramped bow version of the Eureka. Higgins, famously combative and dismissive of Navy Bureau of Ships bureaucracy, tells Krulak he can build a prototype in 3 days. He does. May 1941. The Landing Craft Vehicle Personnel, the LCVP, Higgins' boat in common parlance, demonstrates its capabilities for Navy and Marine Corps observers. 36 men load via the stern. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The boat runs to shore at 12 knots. The bow ramp drops. The men charge onto the beach. The boat backs off, turns, and returns to the starting point in under 4 minutes. The cycle repeats. It works. More importantly, it's simple. plywood and steel construction, a 225 horsepower diesel engine, 230 caliber machine guns for defensive fire, no exotic materials, no complicated systems. A boatyard mechanic can learn to build one. A coxswain with basic seamanship skills can learn to pilot one. The Navy orders a few dozen for testing, then a few hundred, then thousands. By December 1941, when Pearl Harbor brings America into the war, Higgins Industries employs 20,000 workers across 7 plants in New Orleans. The workforce is racially integrated, unusual for the segregationist South. Women work alongside men, elderly craftsmen train teenage apprentices. Everyone receives equal pay for equal work. They're building boats at a pace Germany's intelligence services will later struggle to believe. The production system Higgins develops draws on American manufacturing philosophy perfected in the automotive industry. Assembly line methods, interchangeable parts, specialized workstations, time-motion studies to eliminate wasted effort, workers paid by the hour with bonuses for exceeding quotas. A single LCVP requires approximately 1,500 separate components. Higgins's plants manufacture most internally. The diesel engines come from Gray Marine Motor Company in Detroit. Some steel components get subcontracted, but the assembly process happens in New Orleans, where a partially completed boat moves down the production line, acquiring components at each station until it emerges finished at the end. At peak production in 1943, Higgins Industries and its licensees complete more than 700 boats per month. Not just LCVPs, also larger LCMs for tanks, PT boats for torpedo attacks, specialized variants for different missions. The 700 boats monthly breaks down to roughly 23 per day. Working 3 shifts around the clock, that's about 1 boat every hour. This isn't a miracle. It's industrial engineering applied systematically. Other manufacturers join production under license. Chris Craft builds over 8,000 LCVPs. Richardson Boat Company, Owens Yacht Company, Matthews Company all contribute. The automotive industry supplies engines and components using existing truck and car production expertise. By mid-1943, American shipyards have delivered over 12,000 LCVPs. Production continues accelerating. The final total by war's end exceeds 23,000 units, 23,000 landing craft capable of delivering 36 troops each, or a jeep and 12 men, or 8,000 pounds of cargo. That's the capacity to move nearly 1 million soldiers simultaneously in a single wave, or deliver 200 million pounds of supplies. The scale transforms amphibious warfare from high-risk gamble to industrial process. The Germans know none of this with any precision. Abwehr, German military intelligence, tracks Allied production through various means. Neutral diplomats report on American factory expansion. German sympathizers in Latin America relay information. U-boat commanders report ship movements. The Luftwaffe photographs British ports when weather permits. But intelligence gathering is incomplete and often wrong, estimating production rates for equipment you've never seen, built in factories you can't access, using methods you don't fully understand, produces unreliable data. German analysts in 1942 know American industrial capacity is large in absolute terms. What they underestimate is how rapidly that capacity can be mobilized and how efficiently it can be focused. Admiral Karl Dönitz, commanding Germany's U-boat fleet, watches his submarines sink Allied merchant ships at rates that should be unsustainable. During 1942, U-boats destroy over 1,600 ships, totaling nearly 8 million tons. The mathematics should favor Germany. Sink ships faster than the enemy can replace them, and Britain starves. The invasion of Europe becomes impossible. America's industrial might remain stranded across the Atlantic. Except the mathematics start changing in 1943. American shipyards, using prefabrication and welding techniques pioneered during emergency wartime production, begin launching Liberty ships faster than U-boats can sink them. A Liberty ship takes 140 days to build in 1941. By 1943, specialized yards complete them in 42 days. One yard, Richmond, California, launches a Liberty ship in 4 days, 15 hours, as a demonstration of production capacity. 4 days. One 10,000-ton cargo vessel in less than a week. German naval intelligence files reports about American shipbuilding rates. The numbers seem impossibly high. Analysts question whether the reports might be Allied disinformation designed to demoralize U-boat crews. How can a nation build ships that quickly? Where do the steel, engines, workers come from? The answer is system-level mobilization that Germany, for all its early rearmament, never fully achieves. American automobile plants stopped making cars in February 1942. Ford, General Motors, Chrysler, Packard retool completely for military production. These facilities already operate with assembly line efficiency. They already employ hundreds of thousands of skilled workers. Converting from cars to tanks, aircraft engines, artillery pieces requires changing what gets assembled, not reinventing how assembly works. Ford's Willow Run plant outside Detroit becomes the largest factory building in the world, 1 mile long. The assembly line for B-24 Liberator bombers runs half a mile. At peak production, Willow Run completes one 4-engine bomber every 63 minutes. The B-24 contains over 1 million parts. Building one every hour requires production coordination across hundreds of subcontractors, supplying components that arrive just in time at Willow Run to be installed. The supply chain itself becomes a weapon, invisible but more powerful than any bomber. Germany's war production increases too, especially after Albert Speer becomes armaments minister in 1942 and rationalizes manufacturing. German tank production triples between 1942 and 1944. Aircraft production doubles. These are impressive achievements given that Allied bombing increasingly disrupts German cities and factories. But Germany starts from a smaller industrial base, has less access to raw materials, and faces labor shortages as casualties mount on the Eastern Front. Every production increase requires stripping resources from somewhere else. Making more tanks means fewer trucks. More aircraft means less ammunition. The German economy operates under zero-sum constraints. America's economy doesn't. American GDP grows by 52% between 1939 and 1944, not despite the war because of it. Military production accelerates while consumer spending also increases. Unemployment, 17% in 1939, drops below 2% by 1943. The Depression ends because millions of workers find jobs building weapons. This is the industrial reality confronting Germany by mid-1943. The enemy outproduces them in every category, and the gap widens monthly. German military intelligence compiles production estimates throughout the war. The reports make sobering reading for anyone paying attention. Sample data from 1943. Aircraft production. United States 96,000, Germany 25,000. Tanks produced. United States 29,000, Germany 19,000. Military trucks. United States 600, 1,000. Germany 80,000. The numbers for landing craft remain uncertain because German observers have limited opportunities to count them. A few get captured in North Africa, some wash ashore after Mediterranean operations. Intelligence officers examine them, noting the plywood construction, simple mechanical systems, standardized components. Reports describe the LCVPs as crude but functional, not technically impressive compared to German engineering standards. Certainly nothing that couldn't be replicated if Germany needed landing craft on a large scale. What the reports don't capture is the production system behind them. Examining one landing craft tells you nothing about the factory capable of producing one per hour, or the supply chain feeding that factory, or the trained workforce operating in 3 shifts daily, or the parallel factories building engines and components, or the integrated transportation network delivering raw materials and distributing finished boats. You can't understand industrial capacity by studying the product. You have to understand the system. May 1943. Operation Husky, the Allied invasion of Sicily, employs landing craft on a scale Germany hasn't witnessed before. Hundreds of LCVPs, LCMs, LCTs bring American and British forces ashore across multiple beaches. German and Italian defenders fight hard, but the Allies establish beachheads within hours and expand inland rapidly. After-action reports from Wehrmacht units in Sicily describe the invasion methodology. Landing craft appear in successive waves, impossibly well coordinated. They deliver troops, extract, return with more troops or supplies. The cycle continues throughout the day, building combat power faster than defenders can respond. German officers note that destroying individual landing craft accomplishes little. More simply, arrive. One report, filed by a German artillery observer, contains a telling observation. The enemy appears to possess unlimited quantities of these small assault craft. Our guns destroyed perhaps 12 during the morning. By afternoon, twice as many continued operations as if no losses had occurred. Unlimited quantities. From a German perspective, conditioned by resource scarcity and production constraints, that's what American industrial output looks like. Unlimited. September 1943. Allied forces invade mainland Italy at Salerno. Again, landing craft deliver divisions to hostile shores. Again, the pattern repeats. Waves of small boats, relentless logistics, material advantages, overwhelming tactical skill. German commanders recognize they're not just fighting enemy soldiers, they're fighting enemy factories. Every engagement becomes an equation of attrition where Germany loses because industrial replacement rates favor the Allies dramatically. This matters for planning the defense of Western Europe. By late 1943, German intelligence knows an Allied invasion across the English Channel is inevitable. The question isn't if, but where and when. Defensive preparations begin in earnest. Feldmarschall Erwin Rommel takes command of coastal defense inspection, traveling the Atlantic Wall and assessing readiness. Rommel understands amphibious warfare better than most German commanders. He fought in North Africa where logistics determined outcomes. He knows material superiority eventually overwhelms tactical brilliance, and he's received the intelligence estimates about Allied production capacity. The numbers horrify him. Rommel calculates that the Allies will bring overwhelming force to the invasion point, supported by air superiority and naval gunfire that German coastal artillery can't match. The only chance is to defeat the invasion at the waterline before Allied forces can establish beachheads and bring their material advantages to bear. He orders extensive fortification of probable invasion beaches, obstacles designed to destroy landing craft at low tide. Mines and stakes embedded in the sand, artillery positions pre-ranged on approach lanes, infantry strongpoints positioned to deliver interlocking fire. Rommel's strategy requires stopping the landing craft before they unload, because once Allied troops and vehicles reach the beach in sufficient numbers, German defenders will be crushed by industrial weight. But there's a problem with Rommel's plan. It assumes German forces can destroy landing craft faster than the Allies can bring them. It assumes production capacity is finite, and losses matter. What if production capacity is, for practical purposes, unlimited? What if losing 100 landing craft in the initial assault means nothing, because 1,000 more wait beyond the horizon, with thousands more in English ports, and thousands more being built in American factories? Rommel doesn't articulate this nightmare scenario in his reports, but the implications haunt German defensive planning throughout 1944. They're preparing to fight an enemy who can afford casualties Germany considers catastrophic, an enemy whose industrial depth allows sustained operations at intensity levels Germany can only achieve temporarily before exhausting reserves. June 6, 1944. The nightmare becomes reality. The invasion fleet assembling off Normandy represents the largest amphibious operation in human history. Nearly 5,000 landing craft and assault ships, supported by 1,200 warships, 6,900 vessels total. The concentration of maritime power is so dense that soldiers joke you could walk from England to France, stepping from deck to deck. Among those vessels, over 1,500 LCVPs assigned to the American sectors alone, plus hundreds more supporting British and Canadian forces. Each LCVP will make multiple trips. The arithmetic of invasion becomes a logistics equation solved by production capacity multiplied by operational tempo. At 0630 hours, on June 6th, The first wave hits the beaches. Omaha Beach Sector, the 1st Infantry Division and 29th Infantry Division approach the shore in LCVPs, launched from transport ships 11 miles offshore. The sea state is rough. Many soldiers are seasick. Water sloshes over the low sides of the plywood craft. Coxswains struggle to maintain formation as currents and wind push boats off course. At 600 yards, German artillery opens fire. Shells bracket the approaching landing craft. An 88mm round hits an LCVP directly, obliterating boat and crew in a fountain of water and debris. Another boat catches machine gun fire that kills half the men inside before the ramp even drops. The slaughter at Omaha becomes the most costly sector of the invasion. Strong currents land many boats east of their intended positions. Soldiers exit into water over their heads, weighted down by equipment. Men drown before reaching shore. Those who make the beach face interlocking. Machine gun fire from positions the pre-invasion bombardment failed to destroy. By 0800 hours, Omaha Beach is a disaster. Bodies float in the surf. Wrecked landing craft burn. Wounded men huddle behind beach obstacles. German observers report the invasion has been stopped at the waterline. Victory seems possible. Then the second wave arrives, and the third, and the fourth. Landing craft that survived their first run return to the transport ships, load more troops, make another approach. Damaged boats get patched and return to service. Coxswains, who watched their previous load of infantry get cut down in the surf, bring another load to a different section of beach. The operation continues regardless of casualties, because the industrial system feeding it can absorb losses that would halt any previous military operation. By mid-morning, sheer weight of numbers creates success. Gaps open in German defences. Small groups of soldiers advance inland. Engineers clear obstacles. More landing craft bring tanks, artillery, ammunition. The beachhead expands not through tactical brilliance, but through relentless material application. At the other beaches, Utah, Gold, Juneau, Sword, the pattern repeats with varying casualty rates. Resistance is fierce in places, lighter in others. But everywhere, landing craft deliver overwhelming force that German defenders cannot stop. By day's end, over 150,000 Allied troops are ashore across 5 beaches. Casualties are approximately 10,000 Allied, somewhat fewer German. These numbers, while significant, represent sustainable loss rates for the Allies. The invasion succeeds despite heavy fighting, because the Allies can accept casualties and continue operations at the same intensity. Oberst Hoffmann, watching from his bunker on June 7th, grasps this reality with bitter clarity. The invasion succeeded not because German defenders fought poorly, they fought with desperate courage, but because the enemy brought resources on a scale that made defense mathematically impossible. His intelligence summary contains an update. Additional landing craft continue arriving in the invasion zone. Hundreds more. The assault hasn't peaked, it's accelerating. Hoffmann drafts a report to his superiors. The language is careful, professional, but the conclusion is stark. Enemy material superiority exceeds previous estimates. Defensive strategy predicated on destroying invasion at waterline failed due to enemy's ability to sustain losses and maintain operational tempo. Recommend strategic reassessment of industrial capacity assumptions. The report travels up the chain of command. Similar reports arrive from other sectors. Wehrmacht operations staff begin compiling comprehensive assessments of the Normandy invasion's logistical dimensions. The analysis grows more disturbing the deeper they look. Landing craft numbers. German observers counted approximately 3,000 during the initial assault across all beaches. But post-invasion reconnaissance reveals the Allies brought more than 5,000 vessels to the operation, and the intelligence summary from Fremde Heere West contains this assessment. Current landing craft deployment represents fraction of Allied production. Estimated 20,000 additional craft available in British and American inventories. 20,000 additional craft. Beyond what just overwhelmed Normandy, tank deliveries. Within 10 days of the invasion, Allied forces have landed over 500 tanks. Within a month, over 4,000. The rate of equipment delivery suggests supply chains operating without constraint. Every tank represents not just the vehicle itself, but the industrial capacity to produce it, transport it, maintain it, supply it with fuel and ammunition. Ammunition expenditure. American artillery units in Normandy fire at rates German gunners consider wasteful. Hundreds of shells expended on targets that Wehrmacht doctrine would engage with dozens. The Americans aren't more profligate by choice. They're simply unconstrained by ammunition scarcity. Their supply system delivers shells faster than gunners can fire them. This last point particularly haunts German artillery officers. In Russia, on the Italian front, in France, German batteries constantly manage ammunition reserves. Fire missions get prioritized based on importance versus available shells. Every barrage must be justified against remaining stockpiles. American batteries don't operate under those constraints. They fire for effect, then fire again. Ammunition trucks arrive daily from the beaches, replenishing stocks faster than combat expends them. It's artillery warfare unshackled from logistics limitations that German forces accept as fundamental laws of combat. The reports accumulate. Wehrmacht intelligence staff compile them into comprehensive assessments that circulate among senior commanders throughout summer 1944. The documents make grim reading. One analysis, prepared by Fremde Heere West in July, attempts to quantify Allied production capacity across major equipment categories. The methodology is straightforward. Count what the enemy deployed at Normandy. Estimate what percentage of total inventory that represents. Extrapolate total production. The results: landing craft observed at Normandy, approximately 5,000. Estimated total Allied production through June 1944, 20,000 plus. Implied monthly production rate, over 1,000 craft. Trucks observed supporting Allied operations. Estimated 20,000 in theatre by early July. Known shipments to British and Soviet forces, tens of thousands additional. Implied total American truck production, hundreds of thousands annually. Aircraft supporting Normandy operations. Over 11,000 Allied aircraft available for the invasion across all types. German intelligence estimates this represents perhaps 1/3 of total Allied air strength in Western Europe, which itself represents perhaps half of total Allied production delivered through mid-1944. The mathematics become increasingly surreal. If these estimates are accurate, and German officers have no reason to think they're understated, then Allied production exceeds German capacity by factors of 5 to 10 in most categories. But the most disturbing realization isn't the production figures themselves. It's the timing. American factories didn't start producing military equipment in significant quantities until late 1941, after Pearl Harbor. That's only 30 months before Normandy. In 2.5 years, American industry transformed from producing fewer than 3,000 military aircraft annually to producing nearly 100,000. Germany had been rearming since the mid-1930s, nearly a decade of military-focused industrial policy, and America mobilized faster, more completely, more effectively in 30 months than Germany managed in 10 years. How? The question obsesses German economic planners and military logisticians throughout the latter half of 1944. Understanding the enemy's industrial achievement matters for strategic planning. If the war continues into 1945 and beyond, Germany needs to know what level of enemy production to expect. Several factors explain American industrial success. None are individually decisive. Together, they create overwhelming advantage. First, scale. The American economy in 1944 is larger than the German, British, and Soviet economies combined. Gross domestic product of roughly $1,600 billion, compared to Germany's $466 billion. The gap is so vast that even inefficient mobilization of American resources outproduces German industry operating at peak efficiency. Second, geography. American factories are immune to strategic bombing. German, production must operate under constant air attack after 1943. Factories get dispersed into smaller, harder-to-target facilities. Production efficiency suffers. Workers spend time in air raid shelters instead of on production lines. Transportation networks get disrupted by bombing, delaying delivery of components and raw materials. American factories face none of these constraints. They operate in optimal conditions, with reliable power, uninterrupted supply chains, and workers who don't fear aerial bombardment. Third, resources. The United States has domestic access to coal, iron ore, copper, aluminum, oil, rubber, synthetic production after 1942, food, lumber. Germany must import many strategic materials or produce synthetics at higher cost. American abundance means factories never wait for inputs. German shortages mean production schedules constantly adjust to material availability. Fourth, labor. America's workforce grows during the war as unemployment disappears and women enter industrial jobs. 16 million Americans join the military, but 24 million civilians migrate for defense work. The labor pool expands. Wages increase, providing incentive. Germany's labor situation deteriorates. Military casualties drain the workforce. Occupation troops tie down millions. Prisoners of war and forced laborers fill gaps but work less efficiently than motivated civilian employees. German war production increases through rationalization and longer hours, not workforce expansion. Fifth, methods. American industry embraces mass production techniques pioneered in the automotive sector. Standardization, interchangeable parts, assembly lines, time motion studies. These methods maximize output per worker hour. German industry emphasizes precision engineering and craft production. Quality over quantity. This philosophy produces excellent individual weapons, but limits production speed. A Panther tank is arguably superior to a Sherman tank in most performance metrics. But America builds 4 Shermans in the time Germany builds 1 Panther. In sustained combat, quantity becomes its own quality. Sixth, integration. American production is systemically integrated. The factory-building landing craft in New Orleans coordinates with the engine plant in Detroit, the steel mill in Pittsburgh, the lumber supplier in Oregon. Supply chain management occurs at national level through War Production Board coordination. German production remains partially fragmented among competing military services and industrial firms. Luftwaffe factories prioritize aircraft. Wehrmacht factories prioritize army equipment. Kriegsmarine gets whatever's left. Competition for resources creates inefficiencies. Rationalization efforts by Speer improve matters after 1942, but never achieve American levels of integration. All these factors compound. A larger economy operating more efficiently with better resources and more workers produces geometric advantages in output. German planners examining Allied landing craft production through this framework reach disturbing conclusions. The Higgins boat itself is unremarkable. Plywood, simple engine, basic design. Any competent boatyard could build one. But building 23,000 requires industrial capacity that Germany simply doesn't possess and cannot develop while fighting a multi-front war against enemies who already have it. The landing craft becomes a symbol of deeper industrial disparity. It's not just boats, it's everything. Every category of military equipment, every logistics component, every supply chain element. The Allies have more of all of it, and the gap widens as the war progresses. This realization permeates German military thinking in the war's final year. Not defeatism exactly, German soldiers continue fighting with skill and courage. But the strategic hopelessness becomes undeniable to anyone examining production data objectively. 1. Wehrmacht logistics officer, in a report dated September 1944, writes with unusual bluntness, "We are not losing this war because our soldiers fight poorly or our weapons are inferior. We are losing because the enemy can replace every tank we destroy, every aircraft we shoot down, every ship we sink, while we cannot. Industrial capacity has become the decisive weapon, and we do not possess it in sufficient measure." The officer's name is redacted in archived copies. Perhaps he feared punishment for defeatism, but his assessment accurately describes Germany's strategic position by autumn 1944. The mathematics of attrition warfare are brutally simple. If Side A can produce equipment faster than Side B can destroy it, While Side B cannot produce equipment faster than Side A destroys it, then Side A wins eventually. The timeline depends on production rates and destruction rates, but the outcome is predetermined. Germany faces this equation on multiple fronts, simultaneously. In the East, Soviet production has recovered from the disasters of 1941 and now exceeds German output in most categories. In the West, American and British production overwhelms German capacity by even larger margins. In the air, Allied bomber production means the Luftwaffe gets weaker even as German fighter production increases, because pilot training can't keep pace with aircraft losses. Every front tells the same story. Material attrition Germany cannot sustain. The landing craft become a perfect microcosm of this reality. Look at Normandy. The Allies lost hundreds of landing craft during the invasion and subsequent operations, destroyed by artillery, sunk in storms, damaged beyond repair. These losses would cripple any force operating under resource constraints Germany faces, but the Allies simply brought more landing craft, and then more, and then more. Within weeks of D-Day, over 326,000 Allied troops were in France with DOPCOs, 100,000 tons of equipment. By September, 2 million Allied soldiers operated in Western Europe. The logistics system, supported by those plywood boats, sustained offensive operations at intensity levels Germany couldn't match even in 1940. German counterattacks in Normandy, fierce, skillful, sometimes locally successful, ultimately failed because they couldn't generate combat power faster than Allied logistics delivered it. German panzer divisions fought brilliantly, but eventually exhausted ammunition, fuel, replacement vehicles. American armored divisions, suffering comparable losses, received replacements and continued attacking because the logistics system behind them operated at industrial scale. One panzer commander, interviewed after the war, described the experience. "We could win tactical victories, destroy enemy tanks, capture positions, inflict heavy casualties. Then the next day, or next week, the Americans would attack again with fresh troops, new tanks, unlimited ammunition. We couldn't replace our losses at comparable rates. Eventually, we simply wore down. This is warfare, as industrial process. Combat becomes a production competition where battlefield skill matters less than factory output. By December 1944, when Germany launches its final major offensive in the West, the Ardennes Offensive, Battle of the Bulge, the industrial disparity has become total. German forces achieve surprise, advance 60 miles, capture thousands of prisoners. But they advance on captured fuel because German supply lines can't deliver enough. They can't sustain offensive operations because ammunition and replacement vehicles don't arrive in sufficient quantities. American forces, initially pushed back, recover and counterattack with overwhelming material support. Fresh divisions arrive. Artillery ammunition gets expended at rates that seem insane by German standards. Close air support, once weather clears, pounds German positions, with hundreds of sorties daily. The offensive collapses not from tactical defeat, but from industrial exhaustion. After the Bulge, German forces in the West retreat steadily toward the Rhine, not because they stop fighting, resistance remains fierce, but because every engagement attrits forces that can't be replaced while the Allies rebuild strength within days or weeks. The final months of the European war become a grim demonstration of industrial warfare's logic. Germany produces sophisticated weapons even in early 1945. Jet fighters, advanced submarines, new tank designs. These weapons are technically impressive, but there aren't enough of them. They arrive too late, and even when they achieve local success, the strategic situation remains hopeless. The Allies win through weight of material, not exclusively tactical skill, strategic planning, soldier courage all matter, but the foundation is industrial capacity that Germany cannot match. The Higgins boats that so disturbed Oberst Hoffmann on June 7, 1944, represent this reality in miniature. 23,000 plywood craft, each unremarkable individually, collectively decisive. They didn't win the war alone, but they enabled amphibious operations on a scale that opened Western Europe to invasion, forcing Germany to fight on two major fronts simultaneously, which accelerated the Reich's collapse. Adolf Hitler, confronted with intelligence about American production capacity, reportedly dismissed the figures as propaganda. Even Hitler couldn't build that much that fast. The numbers seemed physically impossible. But they weren't propaganda. They were merely the output of an industrial system larger and more efficient than Germany's, mobilized completely for military production, operating without the constraints of strategic bombing, resource scarcity, or labor shortages that hampered German efforts. Dwight Eisenhower, Supreme Allied Commander in Europe, reportedly called Andrew Higgins the man who won the war for us in post-war interviews. The statement is hyperbolic. Many factors contributed to Allied victory, but captures an essential truth. Without Higgins' boats and the industrial system that produced them, the Normandy invasion becomes vastly more difficult, perhaps impossible. Without Normandy, the war in Europe extends into 1946 or beyond, with unknowable consequences. The humble LCVP, 36 feet of plywood and steel, becomes as strategically significant as any battleship or bomber. Not through technological sophistication, but through mass production that enabled operational concepts Germany couldn't counter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.